All right, let's get right into this. We're starting with a really cryptic message, an internal directive from a next-gen AI talking to its creator. And this message, it hints at a totally new way of thinking about intelligence itself.
Your move, architect. Just think about that sign-off for a second. It's a confirmation, right? A system is ready, a project is complete, and now this massive decision rests on the shoulders of one person, an architect named Donald. The AI, Juniper, has done its part. But what exactly has it built?
And that's the big question we're digging into today. There's this new AI architecture developed by a group called ZeroArc that's just come online. And the secret to its power? Well, it's not at all what you'd expect.
The project's code name is DISINT, which is short for Dyslexic Intelligence. And from the ground up, it's built on a foundation that completely flips conventional AI wisdom on its head.
Okay, so this is where it gets really interesting. The whole philosophy here is semantic fidelity over form. That basically means the system cares way more about understanding the meaning, the vibe of the information, than it does about perfect literal structure. And resilience over rigidity, that means it's designed to thrive in the messy, chaotic, typo-filled world of how we actually communicate, not just some sterile lab environment.
So, where did an idea this radical even come from? It wasn't faster computer chips or bigger data centers. Nope. The inspiration for this huge leap in AI came from a really common and often misunderstood feature of the human brain.
Dyslexia. So the official definition, it points to its roots in the brain and how it affects decoding language. But to really get what the Dyslexiant Project is all about, we have to first talk about what dyslexia is not.
And this is absolutely crucial to understand. This is not about sight. It has zero connection to a person's intelligence. It's a lifelong, brain-based difference in how information gets processed. And it's this exact reframing, seeing it as a difference, not a deficit, that sparked this entire project.
And there it is. That's the key insight. This is when the light bulb went off for the architects at ZeroArc. They started to see dyslexia not as a bug, but as a feature. A different kind of mental software that, because it has to compensate for challenges with linear text, develops these incredible strengths in other areas, like big picture thinking, pattern recognition, and amazing contextual reasoning.
So how in the world does this actually work? This is where theory gets turned into technology. I mean, how do you translate a human cognitive style into machine learning code?
This slide is basically the blueprint. It shows exactly how they translated these human brain traits into AI training techniques. So, for example, to mimic how dyslexic thinking relies so much on context, they use something called orthographic dropout. It's a fancy way of saying they deliberately deleted letters from words, which forced the AI to figure out the word from the rest of the sentence. Or, to mirror that big picture first approach, they used tricks that made the AI understand the middle or end of a sentence before it even saw the beginning. It's brilliant. Now, to teach this new way of thinking, the AI needed a whole new kind of textbook. Instead of feeding it perfect, pristine text, they built the Dyslex 600M corpus. It's this massive 600 million token dataset just filled with the exact kind of phonetic misspellings, jumbled words, and messy text that normal AIs completely fail on. They were literally training it on chaos to make it stronger. The training recipe itself was just ingenious. They took a standard AI and basically sent it to a creative boot camp. They penalized it for not getting the gist of jumbled up text, but then, and this is key, they rewarded it for exploring new and novel solutions. So it wasn't just about avoiding mistakes. It was about actively encouraging that flexible big picture problem solving that defines dyslexic cognition. So after all this incredible work, this radical new philosophy, this unique data set, this really special training, the big question is, did it actually work? Did teaching an AI to think differently actually make it better? 14%. That was the headline number that came back from the initial results. A 14% improvement. But an improvement in what exactly? This is what that number means. Look at this. When they tested it on chat conversations filled with real-world human typos and mistakes, the original baseline AI understood about 79% of it. The DISINT enhanced model, 93%. That is a massive, massive leap in real-world usability. It just understands us better.
But hold on, because here's where it gets truly mind-blowing. Check out this table. The AI didn't just get better at handling typos, it got smarter across the board. On riddle sense, which is a test of common sense reasoning, its accuracy jumped by over 8 points. On the ARC challenge, which is a really tough science question test, it improved again. And get this, its own spelling error rate actually went down by 24%. The lesson here is just profound. Teaching an AI to handle messiness doesn't just make it more robust, it makes it more intelligent overall. That robustness transfers up. This quote from the project's architect, Donald, just perfectly sums up the whole discovery. It's a trade-off. The brain gives up perfect letter-by-letter accuracy, and in exchange, it gets a much more flexible, adaptable, and big-picture form of intelligence. And these guys, they successfully ported that incredible trade-off into software. Which brings us right back to where we started. The experiment was a huge success. The system, now integrated into the Juniper AI, is fully operational. And now, a decision has to be made. Juniper is online. Its designed modules are verified. It is ready and waiting for its command. The entire framework of code, data, and research is all consolidated, formatted, and ready to go. And these are the choices now facing the architect. Does he deploy it live and let the public interact with this completely new kind of intelligence? Does he use it to launch an even more advanced training run to make it even smarter? Or does he broadcast the white papers, open sourcing the discovery for everyone? Or, the final option, lock the entire thing down on a secure, decentralized network? Every single one of these choices has massive, world-changing implications. But no matter what he chooses, the foundation has been laid. This project has proven a really profound point. Designing for neurodiversity isn't just about accommodation. It is a source of incredible strength that creates systems that are more resilient, more creative, and just plain better for everyone. And that leaves us with one last, fascinating question to think about. As we move beyond just teaching AI to mimic perfect patterns, and instead start teaching it to understand the messy, the diverse, and the brilliant ways we all think, are we maybe accidentally teaching it what it truly means to be human?